So in this lesson, chapter 1.2, we're going to talk about solving linear equations. And generally when we solve something and we solve a linear equation, what we're trying to do is we're trying to find the value of the equation, the value for the variable that makes our equation true. Okay, so we're just going to try to find the value of the equation that makes, in this case, most of the time it'll be x true. And there's a process that we're going to go through. And so here are the steps to actually solving the linear equation. The first thing we want to do is we want to clear the equation of any kind of fraction. So we're going to clear the equation of fractions. And we generally do that by multiplying what's in the denominator of whatever we're talking about. So we're going to multiply, we essentially call that an LCD. We're going to multiply by the LCD, which stands for least common denominator. Then we're going to simplify each side of the equation. And we do this by doing one of two things. We can, if we have a grouping symbol with a number in the front, we can use what's called the distributive property to distribute. Or if we have terms that are the exact same, that have the same variable, we can combine like terms. So our third step is going to be to isolate the variable now. So generally when we solve, we're always trying to isolate some variable. And we can isolate the variable by undoing our PEMDAS operation. And remember what PEMDAS stands for. When we talk about PEMDAS, this is our order of operation. An order of operation combines these two things, addition and subtraction, multiplication and division, and these things are by itself when we talk about our exponents and our parentheses. And generally speaking, we normally do parentheses first, then any kind of thing with exponents. Then we can do multiplication or division, whatever comes next, and then we do addition or subtraction. If we're going to undo that, then we're going to go in the opposite direction, and we're going to start off by trying to isolate the variable by using addition and subtraction first. And we're going to use the opposite operation of that, all right? And then our final step when all this is, so our first step, again, our first step to do the isolation is to add or subtract. And then once we do that, we can isolate the variable again if we need to by, generally we're going to be dividing to solve for the variable. So we're going to divide here. And then our last and final step is to make sure that we check our solutions. And we do that by plugging in. So here is the actual process we're going to follow. So let's look at our first example. On this, it says solve 5x plus 3 is equal to 6x. And notice what we have here. We have the variable x on both sides. In order to solve, you have to move the variable to one side. So to do that, we're always going to move our variable to the side where our variable is bigger. In this case, we're going to start by moving the variable to this side with the 6x. We look at the operation for 5x, and right now there's a plus. It's basically a plus that's sitting here. So we're going to undo it by subtracting 5x on both sides. What happens is by undoing that, it cancels here, and then we're left with just this number 3 that is equal to, well, 6x minus 5x is just x. This right here tells me that the solution is x equals 3. And again, remember, what I want to do is I want to check the solution. So checking means you're going to plug everything. You're going to plug the answer you got of 3 back in for every x that you see here. So we're going to do 5 times 3. That should equal, 5 plus 3. That should equal 6 times 3. And then we notice here, 5 times 3, that is 15, plus 3. That should equal 6 times 3 is 18. And we notice here 15 plus 3 is 18, so 18 equals 18, so that is correct. So let's look at our next problem. Notice here when we go through our steps again, remember what our steps are. Our steps are to clear the equation of any fractions first. We don't see any fractions. But we need to now, step number 2 says to simplify each side of the equation by using either distributive property or combining like terms. Here we can use the distributive property because we see a number sitting in front of a grouping symbol here. So distribute the 3 to both these terms, distribute the 2 to both these terms. And here's what I get now. 1 minus 3 times 2x is a negative 6x. Negative 3 times 9 is a negative 27. That's equal to 2 times 1 is 2. And then 2 times a negative 2x is a negative 4x. Another step in step 3 is to combine like terms. Well, sitting here and here on this side, these are like terms. They're both the ones. So I can combine those terms. And that's 1 minus 27. So now I have this sitting on this side. I have negative 6x minus 26 is equal to 2 minus 4x. And again, now we can start to isolate the variable by either adding or subtracting. And notice here, I told you I want to keep my x's on the side where it's bigger. So you have a negative 6x and a negative 4x. Realize that negative 4x is bigger than negative 6x. Here you're more negative, so this is a bigger number. So we're going to isolate, we're going to move everything to this side. So to do that, I'm going to focus on these two. I'm going to do the opposite operation of this negative here, which will be a positive. So that's plus 4x. This is plus 4x. I'm sorry, plus 6x. That's plus 6x, plus 6x. These are going to cancel. I'm left with negative 26 is equal to 2. And then negative 4x plus 6x is a positive 2x. Now, the next step, again, I need to keep adding to undo the addition, or keep subtracting and adding to undo each other. So here I'm going to isolate this variable 2x. To do that, I need to move everything away from it. So I'm going to undo the positive 2 here by subtracting 2 on both sides. When I do that, I get negative 28. That's equal to 2x. The final step is to undo again by division now, because this operation, when I undo, I want to isolate the x. I'm going to undo the multiplication with division, so that's a 2. And here's a 2. And so I get negative 14 is equal to x. And again, we can check our solutions. To check it, we just plug back in. So 1 minus 3 times 2 times negative 14 plus 9 is equal to 2 times 1 minus 2 times negative 14. So cleaning this up, here's what I get. 1 minus 2 times negative 14, the negative 28, so that's 3 times negative 28, plus 9 should equal 2 times 1. Negative 2 times negative 14 is a positive 28. And I forgot my parentheses around this right here. So next thing I'm going to do is this part right here inside of the parentheses from PEMDAS. And so that's 1 minus 3 times negative 28 plus 9 is a negative 19 equals 2 times 1 plus 28 is 29. And so now we're going to distribute. Multiplication comes next. Distribute this. And realize that's a negative 3 times a negative 19. So I'm going to get 1 plus 3 times negative 3 times 19 is 57. That should equal 2 times 29 is 58. And so I get 58 is equal to 58. That is the correct solution. And so in our last problem, notice that we have all of these fractions. So our first step again is to clear our fractions. In order to clear the fraction, what I'm looking for is what we call our LCD, the least common denominator. Well, I need to find a number that 3, 6, and 2 all have in common, a multiple of each one of these, and I want the smallest multiple they all have in common. And for this case, if I look at it, I know that the multiple between 3, 6, and 2 is going to be the number 6. So I need to multiply each one of these fractions, the denominators, by a number to make them be equal to 6. And so when I do that, if I take 1/3, I can multiply that by 2, because that'll make this bottom 3 become a 6. If I take 5/6, I'm just going to multiply that by 1, because that's already a 6. And then I'll take this 1/2, and I'll multiply that by 3. Then I'll make that bottom 6. And then realize that this 6, this x right here, in the end, is really x over 1. So I need to multiply this one by, I need to remember what the denominator is, 6. And I can write any kind of whole number. And remember, there is a 1 in front of this x, understood to be a 1. So I can write any kind of whole number over 1 and keep it the same. So then multiply this one by 6. And so whatever I multiply on the bottom, I also have to do on the top. So here's what's going to happen. I'm going to get 2 over 6 plus 5 over 6x is equal to 3 over 6 plus 6x over 6. And so what this does now is it puts everything in terms of the same denominator. And because we have the same denominator, we can literally get rid of the denominator. The denominator will go away now. And so what you're really essentially left with is 2 plus 5x is equal to 3 plus 6x. And it's just me taking the top of the problem, looking at the top of the problem. And so what's going to happen now is, remember what we did. We cleared the fraction. There is no combining like terms or distributing anymore. We'll go ahead and isolate the variable by adding or subtracting first. So notice that it's bigger on this side, the 6x. But look at my x's. It's bigger at the 6x. So I'll subtract 5x on both sides. This will go away. And then I'm left with 2 plus 3. 2 is equal to, 2 is equal to 3 plus x. Again, I want to get the x by itself. So now I have this 3, I need to move away from it. So again, by subtraction, I can undo that. So I'll subtract 3 from both sides. And I get that x is equal to a -1. So we can go back and check this. And it's actually easier to check this where our fractions are all the same right here. And we're just going to change every x in this fraction problem right here to -1. So here's what I get. When I go back and check, I get 2, 6. 5, 6 times the -1 is a -5, 6. That's equal to 3, 6. 6 times -1 is a -6, 6. 2, 6 minus 5, 6, because the denominators are the exact same, you can just subtract the tops. 2 minus 5 is a -3. And then over here, the denominators are exactly the same, so subtract the tops. 3 minus 6 is also -3. So it's -3 over 6, -3 over 6, that checks out.